I haven't done attendance either. I'll do attendance. Well, I'll do attendance in a minute. Okay, we want to find the extrema. I know you know how to do this, so I'll just pick some people out of the blue here, like Emily. Do you know what you do to find critical points? Do you remember what you do?
You have to find the value of x that makes the function 0 or undefined.
Yeah. So it's this undefined and 0 thing. So we're looking for places that something is undefined or and 0. Kelsey, do you know what that something is that we're gonna do? Like in Calc 1, what was the first thing you did, even if you didn't know how to solve a problem?
A derivative.
Yeah, so you find where the derivative is either 0 or undefined. So that's what we're going to do here, is we're going to find where the derivative is either 0 or undefined. And Aiken, I know you know how to do this derivative. What is this derivative? So remember, multiply by the power. To the fourth. Very good. Very good. And I'll leave that 5 down there in the negative. And then what about that 3x cubed? What happens?
Plus 9x or 2.
Okay, and then what happens to that 1? Nothing. It goes away. It ends up being 0. Very good. So plus 0. So there's my derivative, and I want to know, as Emily said, where is the derivative? 0. Where is it undefined? So that's where critical points are. So critical points, let me just remind you, critical points are where the derivative is 0 or where the derivative is undefined. And the undefined business, that often gets forgotten because we deal with so many polynomials like this that is never undefined. So you don't even have to worry about the undefined. But don't forget undefined is important every now and then. Okay, so go ahead, set that equal to 0. So let me go ahead and do this. 4 plus 9x squared equals 0. And I think I picked a nice function for you, didn't I? So take a minute, solve that thing while I do attendance. More tools, take attendance. Who is not here? You're not here. Huh. Oh, he's not here either. Leave us with the right number. 18. 20. 20. 1, 2, 3, 4, 5, 6, 7. There's one more missing. I got to figure out who it is. Oh, I see. Okay, I got him. Okay, submitted. Let's do this together. Who do we have? We have Luke. Luke is dying to tell me about the solutions to this particular equation. What did you get, Luke? 0 and 3. You're almost right. You got 2 of the 3. So 0, x equals 3. There's one more. What's the one that he missed? What? It is -3. Very good. So yeah, just don't be, just be careful. What I would suggest you do is to factor instead of what you probably did, which was you moved the x to the 4th over to the other side and then divided by x squared. But let's go ahead and factor this just to see how this works. X to the 4th minus 9x squared equals 0. So that means you have x squared times x plus 3 times x minus 3 equals 0. So there's my, there are my critical points, 3 critical points. Now, critical points are critical because they could be maxes or mins. Just to remind you what that means is if you have a function that looks like this, okay, whatever, the critical points are going to be the places where the slope is 0 or undefined. So it could be a maximum, could be a minimum. That's why we care about them. But there's one other thing that you could have as a critical point. Does anyone know what that third option is? It could be a max, could be a min. What's the other one? Did you? Oh, okay, yeah, it's related. It is a point of inflection of sorts. It's a point of inflection that looks like this, where you level off, and then you keep going up. Okay, I did my best to make that look flat there, but So their slope is 0. So you can either have a max or a min, or this is a point of inflection, but more importantly, it is a place where it levels off and then keeps going up, the graph of the function. So let's find out which is which here. And you probably remember classifying these things as maxes or mins without using your calculator to graph them. So see if you can figure out which these are. By the way, one of these is a maximum, one of these is a minimum, and hold on a minute. Yes, and one of them is neither. So which one is which? And so see if you can figure it out, and then we'll talk about how you did it. Oh, yeah, I forgot about this. As if I wasn't caffeinated enough. All right, let's do this. Rachel J., I know you know that there are 2 different ways to come up with what to classify these. I'm just curious, which way did you use? The original function? Oh, interesting. Yeah, that's not a guarantee of finding out if it's a max or a min. But that gives you the actual point, and that's going to be important to know how high or low. So if you plug this back into the original function, which is this up here, you'll find out what the function values are. The reason why that's not a foolproof way of figuring out if you have a max or a min is that you could have a function that looks like this. Just a minute, this is going to annoy me. I'm just gonna copy this and put it into Notability so it doesn't keep moving around. Hold on a sec. Now I should just always just copy all my PowerPoint into Notability, I think, because it is far superior. There we go. There, paste it in there. Okay, that's better. Okay, so here's why that's not, if you just plug these into this original function, that's good to know, but it's not a foolproof way of figuring out if you have a max or a min. Here's why, bless you. When you plug 0 into this, 0, you get the point. So here, oh, I assume you did do this, didn't you? Let me just do this, just a minute. Whoops. You have x and f of x. So Rachel, you did actually plug these in? Oh, which ones did you do? Okay, so what did you get for positive 3? Okay, 33.4. And then if we do negative 3, I'm going to guess you get negative 31.4. Did anyone plug this in? So I don't know, maybe you're all like, no, I didn't do it because that's not the way to do it. But I'm saying that it's useful to know this stuff. I'm going to guess that that's what it is. It's fine if it's not exact. You can plug it in and tell me if I'm right or wrong. But so here's what we've got. If I graph these points, 0, 1 is one of the points. 3 and 33.4 is another of the points. And then the last point is negative 3 and negative 31, or so. I don't know if that's exactly what it is, but whatever it is, down here somewhere, I'm pretty sure. Let me just double check though in my head. If you put negative 3 in here, you get negative 243, positive 243 divided by 5 plus negative 81 plus 1. It's negative 80. Whatever 243 over 5 is. Well, yeah, I think it's gonna be down there somewhere. It's negative. Okay, so here's the reason why you can't just rely on those dots, is you only have 3 dots there, and that doesn't tell you anything about the function. I know, this is a polynomial, so it probably isn't going to do what I'm about to do. But this function could do something like this. This might be a minimum, but it could be a maximum. How could it be a maximum, you might say? Well, what if the function does something like this? And then goes off to some asymptote. I know it's a polynomial, it doesn't have an asymptote, but just work with me for a sec. And then maybe you go down there and then you come up here and you have this weird, okay, so this thing is just going to be a line now. But you get the picture, kind of goes up and then up further. And then up here, you might have something that looks like that. Could happen. I mean, if all we know is the function values, the function could do something like that. So that's why I can't just rely on function values. I need to know a little bit more about this graph. That's not what this looks like, by the way. That's definitely, it's a polynomial, so it's going to look like a polynomial. That would be a rational function. Okay, so there is another thing that you're going to do, though. There are two methods, like I said. So let's find another volunteer. So Rachel gave us good information, though. Cooper C. Cooper, what do you do? I know you know that there's two methods. Which one do you use?
I also plug it
Just to the function. Okay, so that's like I said there's two methods. That's well, not really a third method. It's a method, but it's not reliable. It's not a reliable method. There are two methods you learned. So let me try one more person and see if we have Andrew. Andrew, which of the methods do you use?
Take the next derivative.
Okay, take the derivative. Oh, the second derivative?
Second derivative of the original.
Fancy. Okay, so what Andrew is doing is he's using the second derivative test. So that's one of the two tests that you might have learned. By the way, the other one is the first derivative test. So first derivative test. I knew I'd get someone to do one of these. And the second derivative test. Okay, so let's do what Andrew did, and then we'll back up and do what some of the rest of you might have done. So what Andrew did was he took this function, and he said, okay, we're going to do the second derivative. Andrew, pray tell, why would you do the second derivative?
The second derivative can tell you the rate at which the slope is changing.
Which is also referred to as concavity. So you would be able to know, is it concave up, which would indicate a minimum, or concave down, which would indicate a maximum. Isn't that beautiful? So let's get this second derivative. That's going to be negative 4x cubed plus 18x. Let me put this down here. Where did my stuff go? Oh, here it is. Okay, so we have f double prime is negative 4x cubed plus 18x. And then we're just going to plug in these three numbers. So we have f double prime evaluated at 0 is 0. F double prime evaluated at 3 is, give me a second here, 27 times 4 plus 27 times 2. So that's going to be 36, negative 36. Whatever it is, it's negative. Technically, we don't even care what number we get there. We just care if it's positive or negative. Okay, the second derivative evaluated at negative 3, I'm going to guess is positive 36. Yeah, because what you get here is 4 times 27, 108. You doing that right? Plus, oh, wait a minute, 54. Oh, I'm off. I'm off by a bit. I don't know why I was thinking that. Here, just a minute. Let's try again. Yeah, like I said, it doesn't really matter if it's positive or negative, but now I get the right. Hopefully I got it right now. Is that right, Andrew? Did you get 54 and negative 54? Oh, sad.
I'm plugging in my calculator.
Okay, but I got the right second derivative, didn't I?
Yeah, the derivative seems fine.
It seems fine. All right, good. I'm so happy.
Yeah,
Okay, good. I got it. At least my mental calculator, even if I can't do physics as efficiently as I thought I could, I'm doing okay. I'm throwing this thing everywhere. Okay, so that's the second derivative test. And so Andrew says that if you have a negative here, that negative means that this is concave down, which means that this point is a maximum. So if you think concave down, you've got a nice curve. It looks like this, concave down, maximum. And if it's concave up, positive means concave up, which means you've got a minimum. So sure enough, this is a minimum, this is a maximum. Now what about this one in between here? That one in between has a second derivative equal to 0. So what does that mean? So Andrew, do you remember what it means for the second derivative to equal 0?
That means it's going up, but then it just flattens out and then goes back up.
Yeah, it might. That means it might do that. It could do all sorts of things. And if you want to know, like, how do you know? Well, here, take this function, for example. X to the fourth looks like this. If you do the second derivative, oh yeah, it's got a minimum, by the way, at 0. So x to the fourth looks like this. The second derivative is 12x squared. And, whoa, and at 0, 12x squared is 0. So, so the second derivative test here is 0, but you have a minimum. So what do you know about it? If you have a 0, you don't know. Don't know. That's the only problem with the second derivative test, is that it's inconclusive if you have second derivative equal to 0. So let's go to the first derivative test, because the first derivative test is conclusive in all ways. Did anyone use the first derivative test? You did? What did you do? How do you do first derivative test?
Okay, so I took the critical points and I split them up into different intervals, and I picked a test value in each interval to see whether the first derivative is negative or positive in that interval.
Oh, very
like
nice.
Between the critical points.
So you might remember doing something like this, making a number line, and then on that number line you put your first derivatives. So the first derivative I'll put up here, maybe in red, that the first derivatives are 0 there, of course, because those are critical points. But then what's going on between the 2 points? So you pick a point like this and this. I would pick numbers like 1 and -1 because those are easy to evaluate, and then plug those in. So it's jogging your memory, isn't it? This is what you did. And so then plug those into that thing that I circled, and you get -1 plus 9. Oh, you get 8 for both of these. Okay, so this is +8. What really matters is the positive. I don't really care about the 8. So I'm just going to put a plus there. Positive slope, positive slope. And then what does that tell us about the thing sandwiched between those? It means that you're going up, 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 and then you level off, and then you keep going up. So that's what that is. Now let's pick 2 more points. And so usually I pick points like 1,000 and -1,000, only because usually those are a lot easier to plug in than numbers like 2, 3, 5, 7. So if I can, I always pick a nice big number. And the reason why is when you plug 1,000 into this, notice that you have 1,000 to the 4th power, which is 1 billion. Wait, 1,000, 1 million, 1 billion, 1 trillion. So it's some huge number, negative, plus 9 times a million. Well, the 1 billion or trillion, the big negative, that's going to make this whole thing negative. Same thing goes down here. That one will be negative. You can use smaller numbers if you don't like my giant number. You can pick the number 4. I don't care. But actually, we're not even going to do this because first derivative test doesn't work in 3 dimensions. But this is a good reminder of how you do this. So notice that so what Emily said was that when you go through -3, you're going down. You're going down, 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 negative slope. You get to -3, it levels off. And then you get to here and you're going up. And then you get here, it levels off, then you go up more, and then you can figure out what this thing looks like. Very nice. So those are the 2 tests that we use. Let's go back here. Unfortunately, oh, come on. It's doing this to me. We can't do this in 2 dimensions. Yeah, 3 dimensions because you have too many things to deal with. But we can still we can guess. And here's how we're going to do this. I bet you can guess what we're going to do. We're going to do exactly what we did in single variable calculus, but we're going to do it for multivariable. And multivariable means multiple first derivatives. We have 2 first derivatives. We've got the derivative in the x direction, derivative in the y direction. Let's compute them. F sub x, f sub y. And I'll bet you can do this in your head, but I'll give you a minute just to collect your thoughts. Take a deep breath, and then we'll do it. All right, Ryan, what do you have for your derivative in the x direction? 2xy, very good. All right, Cooper Stiegel, what do you have for the derivative in the y direction?
-y squared plus x squared.
All right, very